Hi, friends. I'm Jim Rapsas. I'm the creator of Strange Days at Blake Holsey High, and this is the second edition of Holsey Howler, which is your look behind the scenes at the show and things going on, particularly with the new web series Echoes. This week, I am thrilled to be joined by Dave Brody, who was the science consultant on the first two episodes of Echoes. Dave and I go back longer than either one of us would care to imagine or talk about. But when I came up with this idea for Echoes and this character of Iris, the astronomer, there was only one person I thought of to call to make sure I was getting this at least as right as I could in this sci-fi universe of strange days that we're living in. And that was Dave. Dave, thanks so much for joining me today.
It is my total pleasure, Jim. I think we should say at the outset that I'm not a scientist, I'm a journalist, but I get to cover this stuff, and that makes me the dumbest guy in the room usually, which makes me require that people explain it to me. So if they can explain it to me, perhaps I can explain it all to you.
Well, you're the smartest guy I know when it comes to all this stuff. So I'm really thrilled that you're able to come here and talk about it. The first thing that struck me when I started looking into this and investigating a bit was, astronomer like Iris, when they're like searching the skies, they're not necessarily discovering things just by themselves anymore. That there's this whole thing called collaborative astronomy that we show as best as we could in the first episode, given our resources. But tell me how that works.
So in rough outlines, now there is the internet. So no longer do you have to send telegrams from observatory to observatory or call people on the phone. There are worldwide chats. So when somebody discovers something interesting, an observatory picks up something new or anomalous, it can alert the world, and other researchers who have interest in that subject matter will be tracking this. This is precisely what happened in the real world on August 17th of 2017, when the laser interferometer gravitational wave observatories discovered something new, a gravitational wave passing through the Earth, and alerted the rest of the world. And astronomers went and looked with their various telescopes at various wavelengths, and lo and behold, they found a signature on the sky that corresponds to the event that the Laser Interferometer Gravitational Wave Observatory, LIGO for short, actually first discovered. So now we are in a new era of big astronomy, where discoveries are hardly made by, Galileo with his little tube in the backyard looking at the moon, one solo guy. Now any number can play, including citizen scientists, citizen astronomers. And you reflect that very, very well in episode 1 of Echoes.
Glad to hear you say that. So when these astronomers sense a gravitational wave, does that necessarily mean neutron star or black hole?
It most probably does, but big catastrophes in the universe produce stretching and squeezing of the fabric of space-time. When there are large masses involved, when masses move very rapidly, they produce gravitational waves. So far, the gravitational waves that have been detected mostly correspond to mergers of either neutron star with neutron star with black hole with black hole. But particularly in the case of neutron stars colliding and merging, that produces a signal that is available at other wavelengths. It's called a kilonova, astronomers call it, like supernova or nova, a brightening, which is the material that is not included in the merger heats up and gets blown away into space. It will produce a bright flash that will dim throughout time as it expands, and it will change wavelength as it cools and expands. So different telescopes, X-ray telescopes, infrared telescopes, gamma ray observatories can all see this event and make it correspond to, or discover if it does correspond to, a gravitational wave detection. And that informs everybody more about what's going on. So yes, a couple of different things can cause gravitational waves, but neutron star merger, as you do in the show, is one that's really fascinating.
The other thing I thought was fascinating was this whole idea of element detection, that when this happens, they can actually tell the elements that this collision released. And I remember we were having a little online chat, and I said, the element palladium is part of like the canon of the show and plays a role in the show. Is like, might this a thing like this detect palladium? And you said, hell yeah. And I got really excited about that. So tell me about how this works and what sort of elements are detected when something like this happens?
Sure. Well, let's back up a step. All of the higher elements in our world, in our bodies, in our Skype computers, all of those higher order elements, basically everything above iron, was created in either a supernova explosion or the merger of two neutron stars, each neutron star is itself the product of a supernova explosion. That's the way the universe enriches itself, and it's what makes you and me possible. So the gold in my wedding ring, the palladium in my jewelry was created either in a supernova or in the merger of two neutron stars. So yes, this really does happen in the real universe, and it's how we're allowed to exist.
And you've written some articles about this, and again, found this completely fascinating. And we addressed this also. We talk about the Sudbury crater in the show in Canada, and how there's like certain elements are found there and a few other places. So that's kind of like the delivery system, right? These things kind of crashing into Earth in the past, and then that's how all these elements are found and mined. Is that right?
That is one of the ways that they get delivered. Before that can happen, you have to have an Earth that forms in the first place. And that Earth forms out of a gaseous cloud that contains these higher order elements. So at the beginning of the universe, we've recently seen the James Webb Space Telescope first images looking very, very far back in time. The first image that was released was of this menagerie of galaxies. And if you look not at the bright ones in the front, but way, way down deep at the tiny red ones in the back, we're looking back 13 billion years in time. When you look out in space, you look back in time. At that time, there were very few higher order elements, if any. The earliest stars were only made out of hydrogen and helium. They were huge stars. But when they collapsed and went supernova, they started building higher order elements that step higher and higher on the periodic chart. So that comes about 5 billion years ago, here in our own local part of the Milky Way galaxy, there was a big cloud of material that had already been enriched with higher order elements. Some of that cloud came together to form Earth. Some of it formed the sun. Most of it formed the sun. A good bit of it formed Jupiter and the other planets, but also smaller stuff like asteroids, planets that didn't make it, protoplanets that formed and then crashed into each other and broke apart. And you get this differentiation of elements at the core of these things. The metals tend to sink to the bottom. Some asteroids are shards left over from planetary collisions, and some of those asteroids are very rich in metals, particularly palladium and gold and nickel especially, talking about Sudbury. And those asteroids have crashed into Earth, and we have pockets of enrichment where we go and mine them and make stuff out of them. Nobody has any spare change in their pocket anymore because everything is now credit cards and e-cash. But you used to be able to flip somebody a nickel, and that came out of a mine in Ontario, which came out of an asteroid that crashed into the Earth billions of years ago.
And that's,
so yeah, that's the way we get.
That's one of the oldest craters on Earth, right? Isn't it?
One of. Now, Earth is peculiar because it has weather. Unlike many of the other planets that you see them as they were billions of years ago, Earth is changing all the time. So craters form and then get erased by geological processes, and we have to look deeper and deeper into the Earth and do some detective work to find craters that happen further and further back. But originally, it was all a conglomeration of asteroids and comets that fell together to form the planet. So we are a crater. It's just, there are some that are still recognizable, and that is one of the oldest.
And then just briefly, because it's so central to the mythos of the show, talk about black holes. The more I read about black holes, you realize the more we learn, it's probably the more we don't know what we don't know. One of the questions I have about black holes, and I Googled and wasn't sure I got the exact answer to, maybe because there's not an answer to. So we know things get torn apart atom by atom when they go in, but we don't know where that matter goes. Is that correct?
That is correct. We do not know for sure. There are a lot of theories. So the black hole itself, you can't see, because by definition, A black hole is an object that has so much gravity. It is contracted to the point where its gravity is so high that no information can escape from it, including light. So it turns black, meaning it disappears, it's invisible. And you can only infer its presence by what it does to its local neighborhood. You know, it rips gas and stars apart and they start swirling around and they fluoresce brightly. And the dark part in the center is where the black hole lives. The first thing that you see as you go in is something called the event horizon. That's the point past which nothing can escape. But that's not the black hole itself. The black hole itself is smaller, sometimes much smaller. And that's a thing called a singularity. We don't know what happens when you go over the event horizon, between the event horizon and the singularity. Stephen Hawking's favorite saying, one of his favorite sayings is that, you get spaghettified, you get stretched infinitely long into spaghetti. There is newer research that seems to indicate that long before you get spaghettified, you hit a place where your atoms are ripped apart. So it's like trying to walk through a wall of fire. You're not going to make it through. Dust and ash is going to come out the top and nothing is going to make it through to the other side. And that is the current thinking as to what happens to you or any bit of information that enters a black hole. But we don't know for sure. Now, the trick, the conceit of Strange Days at Blake Holsey High, is that somehow information can survive past the event horizon. And it gets even trickier than that. Somehow it can stay together in a coherent form and find its way out to another location in space-time. So you get the idea of transport. We don't know that it can't happen. So you're free to write whatever you want, Jim.
Yeah, this is great fodder for science fiction. And, we have alternatively called it a vortex, a wormhole, an Einstein-Rosen bridge. And, and that was calculated because the idea is like they're calling it a black hole because it's a great name for a TV show. But the characters really don't understand this thing yet or understand what it is. And like I said, that is just great fodder for story. The fact that we know that matter goes somewhere, but the fact that we don't know where it goes and what's on the other side, is there an exhaust port? We don't know, is just a great place for the imagination to run wild for me.
Yeah, we don't know what we don't know. I mean, it's like asking the question, what existed before the Big Bang? It's an irrational question, but yet it's a very important question. You and I, as television professionals, know that what happened before the Big Bang was bars and time. But, that's just our little nerd. We don't know what happens at the core of the black hole, at the singularity, in terms of the preservation of information, or if there's an exit out the other side. The betting is no. We don't know for sure.
Well, this is great. So much more I want to talk to you about. We haven't even talked about the multiverse yet, but I think we're going to save that for another time. I've got helicopters circling all of a sudden, so it's probably a good time to say goodbye. But Dave, thanks so much. This was great. And I'll put some information for you in the notes of this episode so people can find out more about you, where they can find the stuff you've written, videos you've made, and all that. Thank you so much, Dave. Really appreciate it.
My total pleasure, Jim. And good luck with the rest of the series. I look forward to watching and maybe helping with it.
All right. Yeah, absolutely will. And that's it for this episode, guys. Thanks for joining me. And I'll be back again in a couple weeks with something new. See you, everyone.